Hi, everyone, and thank you for joining us today on our Multi-Cloud Happenings April session. It's a really exciting session because we're really getting down deep and dirty to talk about how to connect Azure and OCI services with full flexibility and automated provisioning. And we have a number of experts on the line with us today to walk us through all these details. So my name is Tammy Bednar, and I'm a product manager, and I focus on our Exadata database services at Cloud@Customer in our public cloud, as well as our base database service. Also with me is my colleague, Suzanne. And Suzanne, you want to say hi and introduce yourself?
Hi, everybody. It's great to be here. Thank you. I'm delighted to be on this session today with James and Arun. So I'm a product manager working in Tammy's team. So we have the same expertise, responsibilities for Exadata database, service-based database in the context of multi-cloud.
Thank you, Suzanne. And then as Suzanne mentioned, we're very honored and very happy to have Arun and James with us today. Arun, you want to introduce yourself?
Sure. Hi, thanks, Tammy. Hi, everyone. My name is Arun Poonia. I'm Principal Solution Architect. I work for OCI, focusing on networking, security, developer services, along with the Interconnect. I'm happy to present it with the Suzanne, Tammy, and James here today.
Thank you so much, Arun. And James, finally, you want to introduce yourself?
Sure. Thanks, Tammy. Hi, everyone. James Ronneberg. I'm part of the Strategic Partnership Organization here at Oracle. I'm responsible for the Microsoft partnership as well as the Azure Interconnect product.
Excellent. Okay, as you can see, we have a number of us on the call today. So if you have any questions as we go through this content, please post your questions in Q&A, and then we can address those as we go along or at the very end. We should have time to address any of the questions that you may have, not only about the content, but if you have general questions about multi-cloud, about your services, we would love to help you answer those for you. So before we get started with some of those details, Suzanne and I thought that we would first talk about, what is, or put everybody on the same page, I should say, what our definition of multi-cloud is. And we have a number of solutions. So Suzanne, we have something here called full stack application solution architecture, I should say. What is that? What does that mean exactly?
So when we're talking about the full stack, you can see in this diagram on the very left that we've got the OCI represented in red. And this is the full stack because we're talking about a complete workload. So we've got the application, in this case, running eBusiness Suite, and that's running against Exadata Cloud Services. However, it also, as an overall workload, needs to take data and communicate with another application running in another cloud, in this case Azure, as a custom application. And this is very effective when customers need that flexibility to actually run data between both clouds. And that's why we call it a stack to stack, because you've got different applications on one cloud communicating with the other. And then we have the network requirement in between, which we have various solutions for in Oracle in the Azure context. And that's what we're going to be talking about today with Interconnect. So that's an example of the full stack.
That's good, Suzanne. And also just to confirm, so when we say stack to stack, that means that in a different public cloud, they're also running, because we're from the database side, they're probably running an application and a different database store on this other cloud within this particular architecture.
Correct. Usually that is the case, where we're not depicting it here on this particular diagram, but let's say on here we could have SQL Server as the database that's storing the data in this custom application. That's right. Yeah.
Perfect. So there's this second architecture. I think that you and I are both, we really like this architecture. And this is the architecture that really we want to put everybody on the same page. We call this the split stack applications architecture or solution.
Right. And that's just because we're at the forefront with the database management side of the house, and the data will run in the Oracle database service. And they can be any of the OCI database services that we have today, which Arun and James are going to discuss in context of the interconnect. And this will be connecting to an application in another cloud. In this particular case, we're again depicting Azure in blue. And this is where this could be any number of applications that Azure have that would then run against the Oracle database services. So the important thing is here is that between those two, we very especially need this low latency. I mean, that's always the case when you're running, whether you're running in a full stack or a split stack, the low latency across clouds is imperative in order to have your high throughput network connectivity, and always ensure that you've got optimal application performance, which is why we encourage that you always test the applications when running in a multi-cloud architecture.
Okay, perfect. So now I think we have everybody on the same page as far as the types of, when we come to our definition of what a full stack or a split stack model or our architecture is. And just to remind everybody, in case you don't know, we have a number of flexible cloud database options for your data in the cloud. And all of these can work within a multi-cloud solution. If we start over to the left, we have autonomous database. An autonomous database is the easiest database to configure because we've automated a lot of the manual tasks like backups, patching, and things like that, that we know. And I've been around Oracle for many years, and I know how challenging sometimes those kinds of tasks can be. And we've done a lot of work with autonomous database to automate a lot of this functionality. So it eliminates human error. It can scale with, it works with any workload. It can scale any kind of workload or application that you may run with autonomous database with your application. And then as we move over, we have our Exadata database service, which is most flexible. And I think Suzanne and I mentioned that we both focus on Exadata database service that's on cloud at customer or in public cloud. And as you know, Exadata itself, the platform, started out on premises. And so that's the nice thing about the flexibility. That's why we call it most flexible platform, is because you can run it on premises, you can run it in your own data center with cloud at customer. And I think we call that or refer to that as a hybrid cloud solution, where it's still connected to OCI, but you can still, but physically the hardware is still located in your data center. And then of course the public cloud. And so no matter where you run it, you have the same experience of running your applications against the databases running on the Exadata database service. And oh, by the way, if you have an Exadata database service today, in case you didn't know, we have multi-VM capability that provides you the ability to run both autonomous database and an Exadata database type database service on the same system. If you have more questions about that, reach out to me. Happy to fill you in on that. And then finally, we have our base database service, which is where you can run a single database home within a virtual machine. And it's more traditional because this means that you can, when I say traditional, this means that you can run standard edition, you can run enterprise edition on BaseDB, and also on BaseDB, you can either run single instance or you can run a rack clustered database solution also on these services. So Suzanne, I just went through all our services. How does it fit into multi-cloud?
So it's really important that you mentioned the breadth of capability that we have, but for the context of this presentation and this subject for the interconnect, we are only concerned with the actual database services from these selection that run on OCI. And furthermore, the interconnect has this wonderful flexibility that can also run against all the OCI services and not just the database too. And I think if I just may also mention, when we were speaking about the different types of architectures, your split stack, your stacks to stack, that very much concerns the database. I think that was good to clarify. But I think before we hand over to James, we should also mention about how we actually define multi-cloud versus say intercloud, which are industry terms.
Could be, yeah.
Yeah, before we hand over to James. So we've gone through the stack to stack, the split stack, and now the database services. And then James and Arun are going to open it up much into a wider arena. So I just want to say before we hand over the multi-cloud, so Gartner would talk about a multi-cloud strategy in the context that it really is a deliberate use of cloud services from multiple public cloud providers for that same general class of let's say a workload or an application, IT solutions. And you know, there's always really going to be IaaS or PaaS, but not software as a service, not SaaS. And that's where they're coming from with the Gartner definition. It's this deliberate strategy. But as we all know, in some cases, as time evolves and organizations work more with cloud providers, they can also become accidentally embroiled in the multi-cloud strategy, but then they have to make sure that they're very mindful of the governance and you know, things like how they control the actual skill set that's required across the different clouds as well. And this often comes around through mergers and acquisitions, or let's say sometimes inadequate governance. But I think what everybody agrees on is that these deliberate strategies for multi-cloud, they can actually lead to very well-governed, you know, kind of like, you know, ways of implementation, and improve the breadth and access to the technology choices, as well as, you know, competitive cost reduction and innovative best of breed capabilities. So that's where we talk about multi-cloud, using two or more solutions that run the same application, or workload. But intercloud takes it a little bit further, and this is where we're actually allowing active management of data across multiple cloud environments, which is exactly what we're talking about when we talk about our multi-cloud strategies, as we've just explained, with a split stack and the stack to stack. And this is where it's, you know, talking about having that mindful architecture before you start. And this is what James and Arun are going to discuss today with our Interconnect solution. They're going to cover everything from, you know, for example, why we have the partnership, what it involves, engineered interoperability across the clouds, and pricing, which really is important when you're coming to architect, and being mindful of you know, your data egress charges and so forth. So without any further ado, I'll hand it over to you, James, so you can actually begin. Thank you.
Thanks, Suzanne. Okay, James, over to you.
Thanks, Suzanne. Thanks, Tammy. I think Arun's going to pull up the slide deck here. Great. So again, my name is James Ronneberg. I think what I'm going to do is just set the stage a little bit for Arun as we get into the weeds of Interconnect. Tammy had mentioned talking about why we have the partnership and what Interconnect is. So in 2019, Microsoft and OCI decided that creating a partnership was beneficial to both companies as well as our customer base, as we recognize that our customer base really overlaps from an enterprise perspective. So many customers using Windows and .NET, and many customers, those same customers using Oracle databases. And as we look at that landscape, it was really difficult for customers to start moving those workloads to the cloud. For myriad of reasons, whether it's architectural reasons, maybe technical debt, or even when it comes down to it, licensing restrictions. And the partnership really was designed to overcome those sorts of challenges. It allows customers to take those Azure workloads, so those Windows and .NET workloads to Azure, as well as the database to OCI, and have it work very seamlessly. And how we did that was through this Interconnect partnership, and that's really targeting data centers and or regions, cloud regions that are in close enough proximity to achieve very low latency from a networking perspective. So we're either in the same data center, or we're in a data center that's in such close proximity that we get 2 or sub 2 milliseconds latency from a VM to VM testing. That doesn't include a design or firewalls or these sorts of things. But as we tested our own applications as well as Microsoft applications when we started this, we've determined that that's sort of the sweet spot when it comes to performance across a split stack architecture. Next slide, please. So if we take a look at Interconnect from a product standpoint, we really break it up into three components: the technology integration, the application interoperability, and how do we support this for a customer. So technology integration side of things, we did things to make using Interconnect very, very simple for customers, like federated Active Directory, allowing customers to have that seamless interaction between the two clouds. From an application interoperability, that was really when we went down the process of testing our apps and Microsoft apps, making sure that this type of multi-cloud networking solution is valid for these types of workloads. So as you know, Oracle and Microsoft have many mission-critical applications out there. And we went through the process of testing all of those and making sure that from a performance, that the customer is going to see the best possible scenario. And then from a support perspective, we went down the road of a collaborative support model. And I've got a slide, I think, a little bit later where I may be able to walk through that a little bit. But essentially, a customer has the ability to raise a support ticket around Interconnect with either Microsoft or Oracle. And from there, they're gonna ask for permission to engage the other cloud on the customer's behalf. With that permission, both cloud support teams will work together to find root cause and take that to fruition. At the end of the day, each cloud owns its own services. So if it happens to be something outside of the interconnect and the networking side of things, and it's actually an application or the database problem, that's when Oracle will take lead. If it's the database, or if it's an app problem in Azure, then Azure will take lead and take that to resolution, while keeping both the customer and Oracle up to date. Next slide, please. So this slide really depicts two things. One, on the left side, this might actually be what the customer is looking at. So the top box is an on-prem data center. They may connect to Oracle or Azure via Fast Connect or Express Route, maybe even VPN. But that little green box on the bottom there is showing you Interconnect and what Interconnect really is. It's made up of Fast Connect on the OCI side and Express Route on Azure side. And it's really connecting those routers together, either with physical cross connects within the data center or fiber. And on the right side, it really goes through the benefits of using Interconnect. Though you can achieve multi-cloud with many partners, such as Packet Fabric or a Megaport or an Equinix, all very, very great, good solutions. Where it really changes when it's the two cloud partners with no intermediary in between. Where it really changes is when it comes to how low the latency is. So we limit the number of hops, right? And we're in very close proximity. You're going to see an elimination of egress and ingress costs, especially with the local SKU, which is really how Interconnect's design. ExpressRoute has this concept of local, standard, and premium. With local, you'll get access to that single region and have no ingress or egress charges. Oracle does that with Fast Connect inherently. You'll see other benefits, such as the collaborative support, obviously set up in minutes. Interconnect is very, very simple. It takes about 25 to 35 minutes for a customer who's never set up Interconnect before to kind of go through the process step by step and set it up. Next slide, please. Cost always comes up in a conversation around multi-cloud networking. This slide really shows what a 1 gig circuit on both Fast Connect and Express Route looks like, and what that might cost a customer. In this case, you have the 1 gig circuit on OCI, which is $158.10 a month. And then on Microsoft's side, it's the $1,200 a month. As you can see, that is the local SKU, but you do have options within Express Route. So everything's the same sort of standard with Fast Connect. We don't have a bunch of different SKUs there, but on Microsoft's side, they do have several options. So you can choose local, standard, premium. You can choose standard, unlimited, standard, metered. So you have a breadth of options there. It really depends on what you're looking to do. From a local SKU perspective, you have access to a single region. Standard SKU, you're going to have access to geopolitical regions of Azure. And then if you choose premium, you're going to get access to the global regions of Azure from that same circuit. In this pricing, you can see it doesn't include egress or ingress because that is eliminated. And you will get that sub 2 milliseconds or 2 milliseconds latency. Next slide, please. This slide is updated from previous slides. It does show our 41 regions. You can see with the little Microsoft icon there where we're at with Interconnect. We have 12 Interconnect regions globally. That is ever growing because we expand our regions based on our customers' demand, right? So everything we do, either from a feature function perspective or a region perspective, is going to be customer driven. So when we build business cases together, we're really looking for our customers asking for specific regions and or a combination of regions. We build a business case and then we take that and go through the process of build. Next slide, please. And this slide, I'm going to hand over to Arun, who's going to give us a demo and walk a little bit deeper.
Thanks, James. Hi, everyone. So before we jump on demo, the idea here would be give you a walkthrough what's the different pieces which you need to set up an interconnect. And I will also do a quick round trip time between OCI and Azure just to show you. At the same time, we'll also cover some reference architecture and what are the best practice which you can follow along. So a quick demo topology would be, as James mentioned, there are 12 interconnected regions. So ideally, whenever you're trying to set up an interconnect, you choose regions where Azure in close proximity of an OCI region and where interconnect is available. Then based on that region, you select those regions and you set up your use case for POC or demo point of view. In our case, we have selected OCI S-band. So OCI S-band is interconnected with the US East region. So on the left-hand side, you see this Microsoft US East region where we have one of the VNet, compute subnet, and gateway subnet. And the right-hand side is OCI region, which is an S-band. We have one VCN where we have compute subnet. Within the compute subnet, a couple of VMs are sitting. At the same time, a couple of VMs are also available in Azure side. From interconnect point of view, as James also mentioned, interconnect is a combination of Express Route and Fast Connect. So in this case, Fast Connect is an OCI service and Express Route is an Azure service. In Azure service, what you're going to select Express Route partner would be Oracle. And Oracle, you're going to select Azure as a Fast Connect partner. You're going to terminate Fast Connect at the DRG level. In the left-hand side, Express Route will be attached to the VNet gateway. That's how the end-to-end connectivity from routing point of view, Compute VM will know about the routes of OCI through VNet gateway and Express Route and Fast Connect. Similar goes to the OCI side. So what we're going to show, based on this topology, we're going to look at the console, what are the bits and pieces which you need to do from setting up an interconnect. So the first prerequisite of setting an interconnect, you would need to have an Azure tenancy, you would need to have an OCI tenancy, and the required resources, permission, and quota are available, which are prerequisite to set setting up an interconnect. So as you notice, like interconnect is a combination of express route and fast connect. So the first step would be you need to set up an express route circuit. So you can go to an Azure console, choose your express route circuit here, click on create. This will take you to the create icon of express route. Then you choose your subscription where you're trying to create an express route. Choose your resource group. In my case, I already have a resource group. Just in case if you want to create a new one, you can choose a new one. Choose the region. In our case, is the express route will be created into US East. Provide a user-friendly name. Then in our case, like since we are using provider, which is acting as a partner, so the port type is a provider. You're going to choose a new one. There are many providers here which you can select. Since we are setting up an OCI Azure Interconnect, the provider itself would be Oracle. You choose Oracle Fast Connect as a partner. Then you choose peering location. Peering location is the physical location or logical location where interconnect is attached to the Azure region. So in our case, US East will be in Washington, DC. Suppose if you choose another region like in South Africa region, then you're going to choose Johannesburg, similar to Singapore and all. So the idea would be, in our case, we're going to choose peering location will be Washington, DC. Bandwidth. So as we discussed bandwidth part, like there are many options of selecting bandwidth depending on what's your throughput requirement. So if you choose 1 gig on one side, another 1 gig on another side, that will be normal. If you choose more than what's on either end, so it will be throttle at that limit. So the idea would be like depending on what's your throughput requirement, you select the bandwidth. If you have more than 10 gig requirement, you can deploy multiple interconnect circuit and terminate at the same point on the DRG and VNet gateway. So before we select the bandwidth, so the idea would be like there are a couple of SKU. So SKU, just to give you a quick depiction of what those express route SKU are. So this is the express route SKU, which is on one of the official page of an Azure side. So the idea would be express route has a local SKU, standard and premium. Local SKU, as you can see, it gives you access to only one metro circuit within the local region. Standard gives you to the geopolitical region, and premium gives you access to global region. So the idea, like depending on what your footprint would be, like if you have more than one region within the geopolitical, if you have global region, you choose that. At the same time, you might have to consider the pricing on express route because premium, standard, and local, they have different pricing model. And as well as like if you're choosing local, like what's your data pricing model, like if you're choosing unlimited or limited, depending on that, you would have to choose that. But if you are setting one OCI Azure Interconnect, if you choose local as a by default, you will see in a bit, once you select local, billing model of data will be by default will be unlimited. If I select local, it will be by default unlimited. But depending on what you're trying to do in your use case, you can select that, select your bandwidth which you're setting up, select your SKU, select your billing model. So at this point, like the pre-configuration, like what are the minimum configuration to set up an express route are there. You can go ahead and click on review and create. It usually takes like less than 4 or 5 minutes to set up the express route part. But since just to demo purpose, I already have an express route created. So let me close this one here. So what's going to happen, like once you select the express route, it will look something like this. So in this case, provider is an Oracle partner, peering location Washington DC in 50 Mbps is the bandwidth which I selected. You would need to use this service key. So think of this way. This is the authentication key to set up a fast connect. So you would need this service key to set up a fast connect on OCI. So what you're going to do, like you're going to select this service key, go to OCI console. So in our case, OCI console, and the region which we're selecting is Ashburn. So you go to your fast connect here. If you are, as I said, like the prerequisite will be resources, quota, which needs to be there and all. In our case, we are selecting one of the compartment in OCI demo. Compartments are something similar to what we see in Azure side is resource group. So that to set up a fast connect, the first part would be you need to have a DRG. DRG things where all those virtual circuits are terminated. So DRG is a dynamic routing gateway. So it's pretty easy to create a DRG here. You put a name, choose the compartment, and click on create DRG. But for fast connect, what we're gonna do, I'm gonna show you like how what the flow looks like. So you click on fast connect, create fast connect connection. We're gonna choose fast connect partner. There are many partners here similar to what you saw in Azure side, but in our case, since we are selecting Ashburn region, we're gonna choose Microsoft Azure as itself as a partner. So that's like in a nutshell, interconnect is like going between cloud to cloud directly without going to any third party in between. So at the same time, those are physically connected location. So which is gives you like seamless cloud experience between two clouds. So you choose Azure as a partner, then you provide the name which you user-friendly name, and then provide the compartment which you are where you're trying to collect the fast connect. And then you choose the DRG. So as I mentioned, like the fast connect terminates at the DRG. So you'll be selecting the DRG, dynamic routing gateway, and you select the bandwidth. So bandwidth is where you select those on both ends, like what the throughput requirement would be. And this is the partner service key. So the service key which you notice into Azure side, which we can copy from here, and you paste it this service key here. So this service key will ensure, okay, this fast connect is trying to connect to Azure US East region and using this service key. And fast connect or express out of the interconnect itself is also redundant. You will see like some best practice in the next slide. The idea which I'm trying to tell you here, as you see, like this is using BGP routing protocol to learn routes on both ends, and itself is virtually redundant because if just in case the primary BGP failover, then secondary BGP will take over. So the idea would be when you set up an interconnect, you make sure those VNet and VCN addresses are not matching. At the same time, this is BGP request like /30 adder, which should be non-overlapping IP between two clouds, which is pretty common for when you're trying to connect from one network to another network. You shouldn't overlap those IP together. So once you select those BGP/30 adder, you can select BFD, which is a quick failover for BGP. If you want to choose that, you can select that icon and click on create. So at this point, what's going to happen, like since express route was created, fast connect will start trying to provision the circuit, and you will see like after a couple of minutes, you will see the circuit turns into provision state. If you are curious, this is already created circuit before, but the idea would more or less same. This is using Azure partner and virtual circuit in the BGP, which I mentioned, primary and secondary BGP, 2/30 adder, which you would need, and BFD if you want to enable it and all. You will start seeing this circuit turns green is in provision state as a life cycle. At the same time, and those BGP information and the metrics, we will start seeing those connection state and all. Similarly, in express route on Azure side, this will also turn into provision state, and you will see those /30 assigned IP on Azure side. So at this point, what we have seen, like we were able to see express route is created successfully and fast connect, as well as like the interconnect turn healthy on both ends, like the provision state. So ideally, what's going to happen, like the next step, like you would want to extend the connectivity of this interconnect to your resources. Resources could be on Oracle, could be a compute database, and depending on what the use case would be. Similarly, goes to Azure side. So let's take a look into OCI side first, then I'll come to Azure side. So for example, OCI side, it is attached to DRG. Then DRG will take you to the dynamic routing gateway. So let me take that. In DRG, what we have like in OCI, there's a concept of like how we can attach VCNs to gateway, which is a virtual network attachment. So in OCI, we allow like 300 plus VCNs attachment to the same DRG. So this is the one of the VCN, which is virtual cloud network, similar to VNet. So if you see here, this is the VCN attached here. Then you open that VCN here. Within the VCN is like you have like a couple of subnet, right? Within the subnet, like you see the private subnet, compute subnet, where you're gonna deploy the resources and all, right? Then resources would be like where you want to deploy the compute or database resources. So the idea would be like I have two resources, private and public subnet. Within the public subnet, what's going to happen? I already have a couple of VM running. So if I take you to the instances here in the dashboard, I have a VM sitting into this demo VM. And this demo VM is part of the public subnet, which is in the VCN. So ideally, what's going to happen? You would want to route the traffic from the compute VM to Azure side. So just for your curiosity, you can take this public subnet, click on the public route table here, and you would see, oh, I want to reach to this certain CIDR, and how would I go about it? I would go through the DRG. So click on this route table. You can add additional routes if you want to choose them and create those routes depending on which CIDR you're trying to reach to the Azure side. In this case, is 1043. Then click on the DRG here. It will take you to the same page. And that's how you can route the traffic from OCI side at the subnet route table via DRG. And if you're curious to know, okay, does DRG knows the Azure's CIDR and all, you can click on this route table here. Click on get all route rules. So what's going to happen, as you notice, like we are using BGP, so dynamically it will learn the routes of VNet over virtual circuit. So the VNet CIDR is this, the 1040 CIDR is being learned over virtual circuit. So and now the part which I want to tell you, like from the OCI side, you can know the routes are being learned. At the same time, if you go into Azure side, this is the virtual express route, which is attached to the VNet gateway. This is the VNet gateway. Within the VNet gateway, which is attached to the virtual network, this should be the 1040, which you saw on OCI side. This is the 1040. Within the 1040, we have a couple of subnets where you can deploy the resources. For example, gateway subnet, where the VNet gateway is attached. One of the subnet which we're going to look into is the protected subnet, which is 1043, which is a route. So ideally, what's going to happen in this 10 protected subnet, we're going to deploy a couple of VM. So let me take you to the VM page. So my resource group is this one. This is my demo VM. So this demo VM is attached to this protected subnet, which is 1043.4. And if you're curious to know, okay, does my VM knows how to reach to OCI environment? So ideally, what's going to happen, you can see the effective routes at the VM level. So those effective routes are nothing but like through dynamic routing protocol, the routes are being advertised of OCI subnet on Azure VM. So ideally, like you would see 10.10.0.0 and 10.10.1.0 subnet CIDR being advertised and learned over VNet gateway. So you are seeing it here 10.10.1.0 and 10.10.0.0/24. The routes are being advertised over VNet gateway. So that tells you like, okay, the routing point of view is also perfectly fine. VMs knows how to reach between two cloud. Interconnect is being set up. There are a couple of ways you can choose express route, like local, standard, and premium. If you're curious to know what are the pricing point of view, you can go to Azure side pricing calculator. You choose express route depending on which zone, which SKU you're trying to use. The same way goes to Fast Connect. You can see the pricing on a Fast Connect pricing on the OCI calculator. So if I go back to my topology, so this topology, what we just noticed here, we were able to see interconnect is being set up normally fine. VNet gateway, DRG, compute subnet, and all those VMs are connected also normally fine. So what I'm gonna show you, I'm gonna try to connect to one of the VM of compute side on Azure side at the same time on OCI and do a quick ping test just to show you the connectivity at the same time as the latency you would see there also. So on the left, this is the Azure VM, which we are trying to connect, and this is the OCI VM. Sorry. So if you see at 10.10.0.168, this is this should be our OCI VM, which I'll show in a bit, and I'm using the public IP to connect. And this is the Azure VM, which you are trying to connect from on the terminal. So the idea is using public IP, but we're gonna try to connect to this VM over the private IP between Azure and OCI, as well as OCI to Azure. So a quick ping test, I already ran the command before the demo. So if I'm trying to do here, I'm trying to reach to 10.10.0.168, which is an OCI VM, and do a quick ping and it should be able to connect because all the security lists I already opened it, and routing you already noticed everything is routed normally. Same way on OCI side, you trying to reach to the Azure VM using private IP, you should be able to connect normally. So you see, like ideally you would see like the average latency would be like less than 2 milliseconds, only because our topology doesn't have a lot of VCNs, lot of VNet. There's no hub and spoke. So ideally you would want to do a POC to support your use case architecture. So, and that POC is highly recommended because within the POC you will define what is your best performance metrics would be, like what's your application tolerance and all. So that gives you an idea. So this tells you the connectivity part is normally fine, just to show you, okay, I'm definitely using the right IP. This 10.10.10.68, this is the private IP, and the public IP which I connected. At the same time, the VM which I'm trying to use is also the VM of OCI Azure VM using the 10.43.4 IP. And what you have noticed here, like everything, like what I show in the console, everything is documented on the step-by-step instruction of the blog, which will tell you if you are curious to go to each individual steps, you can go follow along. At the same time, this is also recorded like for end user to see, and this is an official page of OCI Azure Interconnect partnership. Within that, you'll find different reference architecture, and there are many aspects of automation. One of the aspects is like you can use Terraform to provision the resources, and because in the end, like Terraform is an Azure also provides a Terraform provider. OCI also provides a Terraform provider. You can use those Terraform provider to provision resources. In this case, interconnect resource along with the VMs and all. And this also tells you that like what is the integration looks fine. If you have use case around disaster recovery, if you have like more than one region where you want to set up as like DR use case, you can also do that based on this provided architecture guidance here. So let me take you back to the, so in this, so at this point with the demo resources and console, we already covered everything more or less. You can follow along the document to know more about it, but we were able to see the connectivity work normally. So now it comes to like, what are the best practice which you can follow along? So you notice like we were selecting a certain port size, which is a basically requirement. What's the throughput and bandwidth, which you need to understand before you try to set up an interconnect. Sometimes your use case would say, oh, I won't want to use like accelerated networking or SRAV at the VM or depending on resource level, which gives you a little bit more performance, so which you can also tune in. We also already looked at the local, standard, and premium SKU from architecture point of view. At the same time, the pricing, which I told you about, like each SKU has an associated pricing attached to that. Ultra performance, there is a reason of ultra performance recommendation because you can enable fast path. Fast path gives you a data improve performance because it usually bypass the VNet gateway and takes you to the host directly. But ultra performance has a little cost associated with on Azure side, which you might have to consider. At the same time, like they are similar to Azure and OCI, they have concept of availability zones, availability domains. So you would want to select which AZ and AD fits you need, because sometimes AZ and AD, those are logical entity, but behind the scene, they could be pointing to a different physical entity. So you would want to validate your use case during a POC, what meets your requirement and all. You can also use like proximity group to make sure that Azure resources falls into the close proximity within the certain AZs and all. We already looked into high availability because, as I said, physically it's already high available, and virtually we also looked into BGP primary and secondary is also highly available. When it comes to encryption, because in the end, like these are physical connection between two data center of Azure and OCI, and by default there's no encryption on top of it, but you can choose any kind of third-party appliance or network virtual appliance like Aviatix or any kind of firewall to support that encryption. You will see like a quick blog reference in this slide, but you can also Google around, like Aviatix also provides the encryption at the same time any other third-party appliance. Okay, now what we're gonna look at a couple of reference architecture, which will give you a broader view, because in the demo we covered only one VC and one VNet, one VM to VM ping. But ideally, in your use case, customer would have more than larger footprint, like more VC and more VNet or a hub and spoke, depending on the resources. But from networking point of view, as you notice, the interconnect is nothing but is a networking pipe between two clouds. So what kind of a service which you choose on either end, it doesn't matter, as long as the routing point of view is going over interconnect, which will allow you to have connectivity between two clouds seamlessly. In this architecture, as you see, like there are a couple of VCNs on the left-hand side, more resources on OCI side. Right-hand side gives you a couple of like VNets, which are attached to the hub VNet. But in the end, like if you want to connect to these, all of them, as long as you define the routes at the subnet level, which says, or go via DRG to reach to Azure, same way go through Azure VNet VM via VNet gateway to OCI, which will ensure that the routing is there, then it will provide you connectivity. Similarly, if you have a use case where you want to have like like firewall where you want to inspect the traffic at the same time, if you want to have a transit connectivity, usually transit adds you extra hop, might not be fully recommended. So the idea like when you want to set up a direct on-prem to connectivity to Azure or on-prem to OCI, it's recommended to have direct connectivity. But some customer would say, oh, I already have footprint, already gone through the approval of security. Why, to make my life easier, can I go through the transit? Ideally you can, but that's not recommended. But this gives you an additional like aspect of like what you can do more around the interconnect. So in this case, like for example, I have an on-prem connectivity to OCI directly over fast connect or VPN, depending on what I'm trying to do and throughput requirement. Then once the traffic terminator on OCI ends, so I have connectivity between Azure and OCI over interconnect. I have a couple of firewall, which is a FortiGate. It could be any third-party firewall. It could be native service, because Azure also support Azure firewall. OCI also support OCI network firewall. So you can choose the firewall and deploy it in the hub and spoke architecture. Similarly, in Azure side, firewall is sitting into hub and spoke architecture. As I mentioned, like James was showing, like Azure Active Directory could be an identity provider to manage the resources on both cloud, which is already supported. So in this case, like on-prem traffic comes to OCI, and directly connectivity is there. But if on-prem wants to go to Azure side, they'll go to the DRG, and on the firewall, you will ensure the traffic destined to Azure go via back to the DRG again. So that's like a transit part, but if this is more of a broader picture, which tells you can use firewall or like a native firewall or third-party firewall to inspect the like IPS, IDS. There are many next generation firewall capability to support your traffic and all. Then at the same time, since we looked into a couple of architecture associated between OCI and Azure, and as you know, like multi-cloud space has many partners associated with, provides you many features and like networking orchestration and associate the multi-cloud feature point of view. So this is a quick reference, which is a Gartner reference, which tells you multi-cloud networking. So there are a couple of partners, which Oracle itself is also partner, as well as Azure itself is also partner. So this tells you like when it comes to like managing the infrastructure, for example, Aviatrix also allows you give like Aviatrix cloud network platform to support multi-cloud orchestration, which will provide you networking resource and provisioning those resources, similar to like encryption, which I told you about. Same goes for Alkira, Arcus, and Cisco and F5. There are many platform of partner services which provide you to support those multi-cloud networking between not just Azure and other clouds also. So the idea here is to give you broader picture, like Oracle and Azure, they both are heavy on partnership and allow you to support those, use those partner solutions to provide your multi-cloud network connectivity. Like at this point, like as an overall look, what we looked into, we looked into like setting up an interconnect, looked at a couple of reference architecture, how the partner solution can also help. I already showed you an example of an OCI Azure Interconnect on the official page, which also has like an instruction of setting up step-by-step instruction, at the same time deploying using interconnect, couple of reference architecture, and and blog reference, which are also available, which will be shared through the slides also. So ideally, like if you have a use case which you want to test out between OCI and Azure Interconnect, you can always reach out to the product team. And the idea would be like you understand your use case, you understand your requirement. Based on the requirement, you will explore which interconnect region fits your need, and based on that, you test out during a POC, and then you define your success criteria and go from there. So the key takeaway which I want to take it from this presentation, like using Interconnect, you can explore two clouds and you can seamlessly use interoperability services between two clouds and support your use case. And as you saw, like from setting up an interconnect, it doesn't take a lot of 3 or 4 screens, which are pretty easy to set up. And outside of that, you can always enhance your use case, and you can do whatever you want to do based on your use case and customer requirement and all. All right, so at this point now, I will pass it back to Suzanne and Tammy and open the floor for any Q&A which attendee might have.
Thank you so much, Arun. You can just leave that slide up there, please. Okay, so thank you so much, Arun and James. This was fantastic information. I hope that all of our attendees find this useful as well. That was a very detailed demo. I'm glad that we could provide that today, Arun. So thank you so much. I hopefully whoever attended today, you like this session. If you would like to see additional content like this around here, we can also, we'd love to provide that for you. Ashish asked how we can get the slides, as it contains a lot of useful info and links. Ashish, let me see if I can post that on Ask Tom after this. I think I used to do this a long time ago. If you do not see the slides, email me directly and I'll send them to you. That's tammy.bednar@oracle.com. But I will try to post them on under the Ask Tom session, by the way. We have an external Slack channel, and there's lots of great conversation going on about our database services, about multi-cloud. So if you're not on our Slack channel, join us here. We'd love to have you join us on our Slack channel. You can just scan the QR code or go to the link to join our Slack channel as well. Okay, with that, I want to again next slide, Arun. I was like scrolling down. Thank you for your questions. I really appreciate that. And I want to thank you for joining us. So for this month, I want to say thank you again very much for joining us. We look forward to you joining us next month on our multi-cloud happening session. And Suzanne, you have any last minute thoughts you want to leave us with?
No, I just wanted to thank Arun and James for that marvelous presentation. Thanks for the support, James, on the Q&A. Yeah, I think we can say that we're next time going to be talking about really the wonderful subject of cross-regional data guard with Oracle Database Service for Azure, and make some clarifications around that, focusing on base database service. So that's what we're going to be talking about next.
Fantastic. All right. Thank you all for joining us, and have a great month, and we'll talk to you next time. Bye now.
Thanks. Bye-bye.